Welcome back, class. After a very long time, I'm here in order to complete the syllabus of organic chemistry. As we have left one unit, that is the last unit of your syllabus. So we will discuss that unit in a different segment. So the topic, the unit is unit number 4, the last unit, and title is alkyl and aryl halide. So we will discuss first the alkyl halide and followed by the aryl halide. So this is the lecture number first of this unit, and hope you all are well where you are living. So let's start the discussion of this topic, alkyl halides. What is alkyl halide? So alkyl halides are actually the derivatives of alkane. Alkyl halide is what? Derivatives of alkanes. So alkane we had already studied in first year, I suppose, first year, or maybe in the second sem also. So derivatives of alkanes, that means if you have a alkane, the simplest one is methane, so CH4, and by replacement of one hydrogen with any halogen, okay, one hydrogen will be replaced and one chlorine will be added, so this will certainly gives you what? Alkyl halide. So the general formula for alkyl halide is what? The general formula is what? Rx. Rx. R is a group. It can be methyl, ethyl, propyl, any group. So Rx is the general formula, and X is the functional group. Okay. Then the classes. So simple classes or classification, you can say that. So classes of alkyl halide, so here we have 1 degree, 2 degree and 3 degree. Okay, 1 degree, 2 degree and 3 degree. So 1 degree is what? If you have R and then C, then H, and if it is connected with X, so this carbon is connected with only one carbon, so this is what? 1 degree alkyl halide. Then C, this is replaced by another R alkyl group, so this is what? The second degree. And then if we have R, C, R dash and R double dash with X, so this will be the third degree. So this is the classes of alkyl halides. These are the excellent solvents. Alkyl halides are actually excellent solvents in many organic materials and in industry. Okay, now the method of formation, the method of preparation, method of preparation. So method of preparation is different methods of preparation we have. So let's start with the very first. The very first method is by the action of hydrogen halide. By the action of hydrogen halide. Hydrogen halide is what? HX. Okay, HX. So this is the first method for the preparation. So for that alcohol will be utilized, We can take any alcohol, like if you take the ethyl alcohol, so ethyl alcohol is CH3 CH2OH, and this ethyl alcohol is combined with hydrogen halide. So here I can take HCl, hydrogen halide, in presence of, that is very important, in presence of zinc chloride, which is anhydrous zinc chloride we need to take. So this will give a very simple reaction, uh, CH3 CH2Cl. Okay, this alcohol OH group will be replaced and water will be released. Okay, so this is very simple method of preparation uh, by the action of hydrogen halide. Now you can prepare second degree alcohol and third degree alcohol also. So if you have a tertiary alcohol like CH3 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 COH plus HCl. Okay, now again no need to repeat this condition, that means the anhydrous zinc chloride, that means easily it will react, because of the tertiary alcohol it will be easily react. Okay, so the result will be Cl plus H2O. Now what these two reactions says, we have a first reaction, we have second reaction. These reactions clearly tell you that the order of reactivity of a different alcohol. So what is the order of reactivity? So I'm writing here the order of reactivity of alcohols. Order of reactivity of alcohol is what we have. The third degree alcohol will be the quickest. So third, second and third, this is the order of reactivity in case of hydrogen halide. Okay, similarly you can prepare the bromide also with HBr. Okay, you can easily prepare bromide also, like if you have a reaction like CH3 CH2OH HBr, this will give CS3 CH2 Br plus H2O. Okay, so this is what the simplest way to preparation. Okay, order you need to remember. Now the second method of preparation of alkyl halide, this is the second method of preparation. So here we will use a different chloride compound. Okay, so we have with by reaction, of what, PCl5 phosphorus chloride, PCl3 and SOCl2 thionyl chloride. So this is the second method of preparation. Again the reacting compound is alcohol, again the reacting compound will be alcohol. So let's start with the very simplest example, CH3 CH2OH. This will react with PCl5, and this is the answer of your one of the question which I asked in the question paper. The structure of PCl5, the all five bonds are not equivalent in PCl5. So here is one of the application of that question. Okay, so with this PCl5 it will give you CH3 CH2Cl plus POCl3 and plus HCl, not HCl, it's POCl3 HCl. Okay, so this is the reason whenever PCl5 react with any compound, these three chlorine atom will combine with the phosphorus. okay, and two chlorine atom will be combined with the other compound. Reason is what? Three chlorine atoms are available at one plane, and two chlorine atoms are available at another plane. Okay, the axial bond, these two chlorine at an axial bond, so these are the weaker chlorine, so this will be easily react. And these three chlorines are at equatorial bonds, these are stronger ones, so this will not react. Okay, so this is the reason of different types of bonding in PCl5. PCl5 is there. Okay, now the second is similarly you can go for the other alcohol also. CH3 CH2OH plus PCl3. Okay, so this will give CH3 CH2Cl, and what is left, that is if PCl3 is there, you will get H3PO3. What is the remaining? CH3 CH2Cl, so this will give you H3PO3 and HCl, H3PO3 and HCl. Okay, so this I'm leaving, I'm not exactly getting, but it should be H3PO3 or HCl. I will check it. Meanwhile you can complete this reaction. And the third one is what? The third one is thionyl chloride. So again we have ECH3CH2OH plus SOCl2, so this will give you CH3CH2Cl plus SO2 and plus HCl. So the importance of the reaction, sometimes the question asks that PCl5, PCl3 and SOCl, both these three are capable to give you ethyl chloride. Which one is a better reagent with alcohol out of PCl5, PCl3 and SOCl2? Which one is a better reagent? So simple reason is what? SOCl2, the thionyl chloride is better. For alcohol, SOCl2 is better. Reason is what? Because in this case we have SO2 gas and HCl. This the side product, the byproduct is what? Sulfur dioxide and HCl, which can easily escape out in air. Okay, the side product byproduct is SO2 and HCl, so this will be removed easily, whereas in these cases the byproducts is not removed very easily. Okay, so SOCl2 is always better. Okay, so this we have discussed two method for the preparation of alkyl halide. Okay, and here you should in presence of pyridine. Okay, pyridine you can use in presence of pyridine. Mechanism is not here, so I'm not discussing the mechanism. Will come in the reaction second segment, so we will discuss over there. So this is what the method for the preparation of two methods we have discussed. Now let's move for the next, and that is this third method for the preparation. So the third method for the preparation is what? The halogenation of alkanes. So the third method is halogenation of alkanes. Now the halogenation is what? Halogenation is, that means the direct halogenation we are talking. Okay, we have alkane compound and we need to give the halogens, so this will give you alkyl halide. So if you go for the general reaction, this is the alkane RH with halogen, this will give Rx plus HX, so this is alkyl halide. Okay, so direct halogenation is possible in with sunlight. Sunlight can be used for the direct halogenation. So chloride chlorination is possible. So in case of direct halogenation, the chlorination is possible with sunlight. So I'm writing chlorination. Okay, so chlorination is what, with halogen, like we have CH4 with Cl2 in presence of what, sunlight. So sunlight, this will give CH3Cl plus HCl. Okay, and one of the problem with this reaction is what, this reaction will continue will continue. Okay, like CH3Cl will combine with another chlorine, so CH3Cl, that is what, methyl chloride will combine with chlorine, so this will give CH2Cl2 and HCl. Then CH2Cl2, another chlorine, so this will give you CHCl3, this is the chloroform, HCl. Then chloroform CHCl3 plus Cl2, and this will give CCl4. So all hydrogen will be replaced. Okay, all hydrogen will be replaced. Here we have one hydrogen replaced, here we have the second hydrogen, here we have third hydrogen, here we have the fourth hydrogen. So this reaction will continue. Okay, and as this reaction will continue, we'll get the mixtures of product. We'll get methyl chloride, also we'll get chloroform, we'll get chloral carbon tetrachloride, methylene chloride, this is the methylene chloride. Okay, this is chloroform, this is the uh, carbon tetrachloride. So the mixture of products and the isolation of methyl chloride is difficult here. You cannot isolate methyl chloride very easily. So this is a drawback for this reaction. Okay, although this is a direct halogenation, you are required nothing. In presence of sunlight, reaction will proceed, but we'll get the mixtures of compound, and this is what one of the problem with this reaction. So what first thing you should remember with this reaction is what, it is a free radical reaction, free radical mechanism is followed. Okay, so here free radical mechanism is follow. Okay, first thing. And the second thing is what, this which I have written here, this is mainly for chlorination. Sunlight reaction is mainly for chlorination. Okay, bromination, iodination, fluorination is not takes place in such manner. Okay, bromination required Lewis acid catalyst. Iodination and other things has a different set of mechanism. We will discuss it, don't worry. So these two things you should remember for this reaction. Chlorination, direct chlorination is possible, but the isolation of product, isolation of product is difficult. Okay, so isolation is not possible in this case. Okay, so now let's uh, discuss halogenation. For we had talked about chlorination. Now in the second case we'll discuss the bromination. Okay, so bromination, and the bromination, sorry, this is wrong. Bromination. Okay, now for bromination, we have two method for the bromination. One is the direct bromination, if you go for the direct bromination, but as I told you, the direct bromination is not possible. We required a Lewis acid catalyst. So if we go for direct bromination, C2H6 with bromine, Br2 in presence of FeBr3. Okay, and this will give you C2H5Br. So one method, you can go for direct bromination, and another method, that is the second method for the bromination, and that is a Neum reaction. You all know that Hunsdiker reaction. Okay, so this is the method of bromination, Hunsdiker reaction. What happened in this reaction, Hunsdiker reaction? So this is the method for the preparation of alkyl bromide. Okay, this is the method for the preparation of alkyl bromide. What is in this method? Silver salt of carboxylic acid, silver salt of carboxylic acid is treated with bromine in presence of CCl4. Silver salt of carboxylic acid uh, treated with bromine in presence of CCl4. Okay, so this will give you alkyl bromide. So let's write the equation here. RCH2 COOAG. See, this is what silver salt. Silver salt, that means this is acid, RCH2COOH. This is what carboxylic acid. Okay, and Ag is the salt. So silver salt, because it is a name reaction, so you cannot change this. Okay, this is always silver salt with bromine. Okay, in presence of CCl4, and this will give you what? RCH2 Br, RCH2Br with release of CO2 carbon dioxide and AgBr. This will precipitate. So this is simplest method for the preparation of bromide compound, alkyl bromide, because CO2 will release, AgBr will precipitate out. And again, this is a free radical mechanism. This is a free radical mechanism. If I go for the mechanism, nothing is special in this mechanism. It will follow the free radical pattern for the mechanism. Okay, so this halogenation is of two type. One is the chlorination and one is the bromination. Now the fluorination and iodination is not possible. Actually, direct fluorination and direct iodination is not possible. Okay, fluorination, because it required a large amount of energy to break the HF molecule or FF molecule, the fluorine molecule, because of the size of the molecule is very small. And iodination will not take place because volatile nature of iodine. Okay, so these fluorination and iodination is not direct bromination. Here I'm writing direct fluorination and iodination is not possible. Reason: for fluorination we require large amount of energy to break the molecule FF, and iodination is volatile in nature. Okay, so what are the other method to prepare these two compounds? Okay, so again we will talk about the preparation for these method, and this is called halide exchange reaction. Okay, so here we are talking about the halogenation of alkanes. So now the next is halide exchange reaction. So what is halide exchange? Okay, so the fourth method is what? Halide exchange reaction. Now in this method, what will happen in halide exchange reaction? See, halide exchange reaction is what? First, this is the very good method for the preparation of alkyl iodide and fluorides. Okay, it is a good method, good method for the preparation of R I and R F. Okay, so what happened in this reaction? In this reaction, actually, uh, exchange of halide occurs. Exchange of halide occurs. Okay, so exchange of halide. So this is actually a name reaction. This is what? This is a name reaction. So that name reaction is what? This is called uh, Finkelstein reaction. F I N K E L S T E I N. Now, what happened in this case? As I told you, this is a halide exchange reaction. So, if we have a halide like RCH2Cl, okay, and then we take a salt. So let's talk, because we need to synthesize Ri. So we'll take the salt of sodium iodide in presence of acetone. In presence of acetone, so halide will be exchange and will get RCH2I plus NaCl. So this is a name reaction. You should remember the name reaction. Here is the method for the preparation of Ri and Rf. Similarly, you can obtain alkyl fluoride also. Okay, you can obtain alkyl fluoride also. Like here we had taken the sodium iodide. In that case, you can take other salt or other inorganic compound. So this is first method, and the second is uh, let's take example of another, that is the chloroform, not chloroform, it is CH3Cl with inorganic compound Hg2F2. The name is the mercurous fluoride. This is mercurous fluoride. Again with the same, this will give you fluoride compound. So this is CH3F and Hg2Cl2. So this is what the exchange of halide. Cl is exchanged with this. Okay, mercurous fluoride. This is mercurous chloride. So this is an again one of the important reaction. You should remember this. The reason is what? Because we cannot synthesize the fluoride and iodide halides direct method. Okay, now we have application of this method also, because this is the method to prepare iodide and fluoride compounds. This is the reaction I have written. So we have application. So very important application in the preparation of freon. So let's talk about the application. So application is for the preparation of freon, Freon 12, freon 12. Okay, so here we have CCl4, carbon tetrachloride, then SbF5. What is the name of this compound? This is the antimony fluoride. Sb is the antimony. SbF5, you can take with 3 also. Here I'm taking 3. Okay, so this will give you CCl2F2. CCl2F2 chloride will be exchanged by 2 fluorine. Okay, So what will get? SbCl3. Okay, you can balance this reaction also. So twice is here, thrice is here, and we have 2, so 2 is here. 6 and 6 12, so here we required 3. So this is carbon tetrachloride. Okay, so this is called uh, difluoromethane. This is what the fluorine name is, dichloro difluoromethane, or freon 12. See, very simple. We have CH. So what is this? This is methane, we know that. And if I replace this with this H with one chlorine, this is another, this is fluorine, and this is fluorine. So this is derivative of methane now. So this is what? Difluoromethane. Okay, it is also chlorofluorocarbon, CFC. Okay, CFC, chlorofluorocarbon, very much used in as a inner, because it is inert in nature, inert gas, so used as a refrigerant in air conditioner and refrigerator. Okay, inert in nature, inert and in toxics also. So it is used in refrigerator and air conditioner. So this is the application of this method also. You should know that what is this. So here we have completed the different method for the preparation of uh, alkyl halide. If we go for one more method for the discussion, we can go for that also. So very simple, I'm not going to discuss in much detail. This is from alkene and alkynes. So from alkene and alkynes, so this is the fifth method for the preparation of alkyl halide. So alkene and alkyne, again with the alkyl we'll take alkene first. So CH3 CH2 CH double bond CH2, and then HBr. So HX is the reactant, this is the alkene. This will follow the Markovnikov rule. Okay, this is the Markovnikov rule. So negative part will go to that side of carbon which has least number of hydrogen. So this is the plus sign and this is the minus. So minus will go to that side because it has least number of hydrogen, and plus will go to this side. Okay, so CH3 CH2 CHBr and CH3. This is the preparation of alkyl halide. And in presence of peroxide, the reaction will be different. So this is follow the Markovnikov rule. This is based on Markovnikov rule. And just check the spelling. Markovnikov rule. Okay, and then we have another method for the preparation. In the same pattern, if we have peroxide, then the pattern will change. It will follow the anti-Markovnikov rule. Okay, so if we have CH3, C double bond CH2 and CH3, and again we have HBr with peroxide. Here we have peroxide. So now what will the change? Here the negative part will goes to the side where we have least number of hydrogen. Here the negative side will go to that part we have maximum number of hydrogen. Okay, so this is the negative part. So what will happen here? Here it will go to this side. That means the negative part will go to this side, and the positive one will go to this side, this carbon. So this will give you result CH3C. This I am not going to discuss in detail because this we had already completed in our previous previous units. Okay, so this is from alkenes and alkynes. And alkynes, let's take an example of alkyne also. So let's take a very simplest example of acetylene. This is the acetylene, and again the reactant is HBr. So this will give you, first it will give you vinyl bromide. So this will give you, again the reaction is same pattern, negative and positive like peroxide. So this will give you CH2 double bond CHBr. So this is what, this is vinyl bromide. Okay, and then again with HBr, what will happen, you will get CH3CHBr2. This is called, this is 1,1 dibromoethane, 1,1 dibromoethane. So this is all about from this lecture. In this lecture we have discussed the introduction of alkyl halide, then this is the introduction of alkyl halide, then classes, methods of preparation is we have different discussed different methods for the preparation, like with hydrogen halide. Then we have phosphorus compounds, hydrogen chloride is there. The very important is the bromination and chlorination, that means the halogenation of alkenes, and then with alkenes and alkyne also. So I think this is enough for this lecture, and with this the first lecture is complete, and I am leaving you for a question. This is the question for this lecture, and I hope you are able to solve this problem. So question is that, how will you synthesize methyl iodide? How will you synthesize methyl iodide from methane? So question is simple: how will you synthesize methyl iodide from methane? And the answer is in within this lecture. So thank you so much for your watching.